Hello, Ritumetse, Shochi. Hi. Yeah, so I just want to have a session, a very brief session with the grade 10s. Grade 10, calling on grade 10s. I think algebraic fraction expressions, we need to have a session together just now on algebraic fraction expressions. I think that's something that's in need of attention for that. It's Omatla. What's your pain? What's your problem at the moment with your grade? Because I see you saying grade 9. So like what section are you guys in at school at the moment, and what's your pain? What's your challenge? I'm not gonna have a grade 9 session today, if that's what maybe you are asking about. But I am willing to entertain a question of yours. If you have a question, is there something that you are finding is a problem or a challenge currently? Where you guys at? What topic? Can you please do 2a squared minus half b squared before doing algebraic expressions? If it's saying 2a squared minus half b squared, my question to you, what is the question about? What is it saying? Shochi. Oh, so you guys are on higher purchase. Okay, that's nice. Factorize. Okay, so Shochi, just to answer your question, so the question that's saying factorize, let's attend to this thing of yours. 2a squared minus half b squared. Okay, so let's take it like this. So we have 2a squared minus half b squared, right? Yeah, so what we can do here, okay, there's a couple of things that we can do. So first and foremost, if you look at the fact that this is 2a squared, I don't know what's happening with my, okay, there it is. Okay, so if we look at taking out the highest common factor, which is the coefficient of a squared, if we take that 2 out, right, what are we left with? We're left with a squared minus 2 times what gives you a half. Okay, that's the $1 million question. 2 times what gives you a half? Do you know? It's 1/4, right? B squared, if that makes any sense. So you have 2 that's taken out as the highest common factor, a squared minus, so you have 1/4, because if you multiply the 2 back, 2 times a quarter will give you back a half. Does that make sense? Okay, so Shochi, I hope you are really paying attention to the question that you asked. You asked me to factorize this thing. So 2, like I said, 2 into the highest common factor. If I take out the 2, I'm left with a squared minus what? So obviously 2 times what gives you a half? It's 1/4. Okay, because 2 goes into 4 in the denominator 2 times. Okay, then what do you have inside the bracket? Because you can still factorize further. Inside the bracket you have a difference of 2 squares, so you're going to open 2 brackets like this. Okay, since it's a difference of 2 perfect squares, then obviously the square root of a squared is a and a. That's what a and a gives you, the a squared back. B squared, obviously there's b and b. Okay, and then the coefficient, a quarter. The square root of a quarter gives you what? A half. So it's 1/2, 1/2. Okay, and then obviously since it's a difference, remember that means a positive and a negative, and that's it. Okay, that's factorized. Okay, that's factorized. In other instances, where other people are concerned, usually what they usually do is, if you look at these two terms, okay, because I guess alternatively some people would look at it this way. So if this is 2a squared, this is half b squared. Maybe let's leave that other way. Okay, hopefully this makes sense. Okay, so this is grade 10. I was just looking at factorization quickly because there was a question that a particular student had asked. Now, before I continue any further, is there anything that anyone kind of feels for grade 10? This is grade 10, guys. Grade 10 learners. I am actually here in this space right now to address any maybe challenges that you feel like you have. I'm sure most of you by now have finished, just depending on your program at school. You've done obviously numbers, real number system. I'm sure you've done and dusted. You've done products. You've done factorization, all the types of factorization. You've done multiplication and division of algebraic fractions, addition and subtraction of algebraic fractions, and probably roundabout now some of you are starting with equations, exponents, the works, right? If not, some of you may well be starting with trigonometry. It will depend on the situation that you have at your respective schools. But yeah, some student actually in the comment section asked me to factorize 2a squared minus half b squared. So when I explained that, the coefficient of a squared here is 2, so I took out 2 as the highest common factor here, and then that left me in brackets with a squared minus a quarter b squared, because 2 times what gives me a half? It's a quarter. Does that make sense? Because if you take the 2 and you multiply with a quarter, you can even check it in your calculator quickly. 2 times a quarter will give me back the half. So hence, I have a quarter b squared. So that highest common factor is out. Then I have a squared minus a quarter b squared. Inside this bracket, I have a difference of 2 perfect squares. So to factorize the difference of 2 squares, I open 2 brackets. Obviously, the square root of a squared is a, so I have a and a. The square root of b squared is b, so I have b and b. And then the square root of 1 over 4 is a half. Half and half. Does that make sense? And then that basically leaves me with what? Plus and minus as my signs inside the bracket. So basically, that's how I factorize that. Okay. Guys, I actually gave, in this week, I gave the grade 10 cohort group that I have, that is part of the Maths is a Game group. I gave them a few problems around factorization, multiplication and products, addition, multiplication and division of algebraic fractions, and addition as well. And so I found that some of the learners still have challenges when it comes to factorization, products, and so forth. So what I want to do is I'm going to just show you I just want to share with you just quickly. I'm just going to quickly share what I basically. Can you add us on a group? The group is already there. There's already a group that's up. I just want to. Let's quickly do this. Okay. I just want to show you what. Okay. No, not this one. Okay, Mbalima Kelane is volunteering herself to actually add you guys. Yeah. So, just very quickly, from those that are on the call right now, if you guys scan through some of the question here, is there any particular question that you guys feel like it needs a bit of attention? Because I gave this to the group to do, and when I did that, I saw that some of the learners were struggling with other types of factorization and some of the questions that are listed here. So if you guys can just scan through what you see on your screen. This was a test, a rotational test. So in the group, I'm currently sending a lot of test questions, all right, to the learners. Why? Because at the end of the day, what I want them to do is to get the hang of exam type questions. So I sent this in the week, and yeah, learners did it. In fact, not all of them did it. I don't know if it's because they were struggling, but people did not indicate what is the issue, what is the problem. So I thought, let me just come onto this live and just share this on here, and then see if there are any common problems that people have. So Mbali says 1.1.1, I still don't understand. So Mbali, if you look at 1.1, look at the statement first. It says given q is equal to, then they have a square root of b squared minus 4ac. So what they are saying now is determine the value of q. Remember, if you look at the given statement, it says q is equal to, all right? And then there's the square root of b squared minus 4ac, right? And then what they are saying is determine the value of q if a is equal to 2, b is equal to -1, and c is equal to -4. And then they say leave your answer in simplest surd form, right? So I'm going to take this off and I'm going to explain what this thing is all about. Just let me just, sorry. I'm sorry guys, I tend to, okay. Yeah, so yes, as the Ndwana says, Ndwane kia, okay. So you want, so Mbali, you want to determine the value of q. And q, right, is the subject, all right. The subject q is equal to the square root of b squared minus 4ac. Now you are told that a is equal to 2, b is equal to -1, and c is equal to -4. So what you do is you write down, obviously you would write down in your answer sheet q is equal to the square root of b squared minus 4ac. And as Ndwana Kia says in the comment section, you go and look, they say a is equal to 2, b is equal to -1. So you say q is equal to, and then in the place of the letters that are given, you substitute, okay, the given numbers, as Ndwane has said in the comment section. So remember, what did they say b is? b is -1. So when you substitute, very importantly, you need to make sure you put what you substitute in brackets. Please, in brackets. -4, remember what's the value of a? A is equal to 2. So then you write 2. What's the value of c? C is equal to -4. Okay, and then after that, all you do now is you actually apply BODMAS and you actually simplify this. So -1 squared, a square applied to a negative sign becomes positive. In fact, any even exponent applied to a negative sign inside a bracket becomes positive. So I know this is +1, okay, minus, now -4 times 2, a negative times a positive is a negative, and then that negative times another negative gives you a what? A positive. Okay, then what's 4 times 2? It's 8. What's 8 times 4? It's 32. Okay, so inside the square root now you have 1 plus 32, which gives you 33. Does that make sense? So now they said leave your answer in what? In surd form. Now surd form simply means leaving your answer as an irrational number. Leaving answer as an irrational number. And since the number underneath the square root is not a perfect square, 33 is not a perfect square, the square root of 33, okay, when a particular number has a square root, and that square root when applied, it basically gives you an irrational number, we call that a surd. Okay, so this is basically surd form. Square root of 33 is what? Is that the form that we call surd form. You don't want to put this in your calculator and write it in decimal form, but you leave it with the square root. So leaving the answer with the square root is what we refer to as surd form. So the value of q is the square root of 33. So I hope Mbali, for instance, the question that you basically had is very clear. So that's how you do 1.1, okay, from a grade 10 standpoint. So hopefully that's clear for you. So let me just go back. I see, let's go back again. So Mbali, you also said, let's see, you said you also 1.3 Is it 1.3 or 1.1.3, Mbali? Is it 1.3 or 1.1.3 that you're having a struggle with? Because I see you said 1.3 and you said 2.1. Okay, 1.3 and 2.1. Okay, so obviously if you look at the next question, 1.1.2, it says state whether q is rational or irrational. And hopefully you can see that the square root of 33, that value of q, which is the square root of 33, is an irrational number. Okay, it's irrational. All right, yeah, definitely irrational, Duane. Thank you so much. Then 1.1.3 says between which two consecutive integers does q lie? Okay, and these are very important questions. You usually get asked these questions a lot in grade 10. Okay, because this is a grade 10 sort of like exercise sheet. So basically they say between which two consecutive integers does q lie? Remember q here is equal to the square root of 33, and this is what we call a surd. And the questions you usually get asked for real numbers in the real number system, they usually do ask you between which two integers does a particular irrational number lie. Okay, so what we do here is we simply look for the two perfect square numbers that lie before 33 and after 33. So what is the perfect square number that lies, the immediate perfect square number that lies before 33? By perfect square numbers, guys, I mean these numbers. For instance, 1 times 1. 1 is a perfect square number. 2 times 2. 4 is a perfect square number. 3 times 3. 9 is a perfect square number. 4 times 4, 16 is a perfect square number. So these are perfect square numbers, numbers that are formed by multiplying a particular natural number by itself. These are perfect square numbers. So I'm asking, what are the two perfect square numbers that lie? One that lies before 33 and one that lies immediately after 33. So miles, kilometers said 25 and 36, and miles, kilometer is 100% spot on. So we have 25. I'm sure you guys know that, because 5 times 5 is 25, whereas 6 times 6 is equal to 36. So 25 and 36 definitely. Okay, before square root of 33 we have 25. After square root of 33, after 33 we have 36, which is a perfect square that lies after that number. What is the square root of 25? It's 5. What is the square root of 36? It is obviously the number 6. So that's why we then say, therefore, the square root of 33 lies between which two consecutive numbers? 5 and 6. And this is what we're always doing, guys, whenever we want to find the two integers, the two consecutive. Remember, the word consecutive means one after the other. So these are the two consecutive numbers by which the square root of 33, this square root of 33 lies between these two consecutive integers. Okay, so hopefully that makes a bit more sense for those that probably were also wondering. Okay, so I'm just taking that that thing one step at a time. Let's just go back again and just relook at this. So that's answered 1.1.2, 1.1.3. Okay. Okay. And then we have 1.2. Okay, 1.2, determine the value of 3p plus q, the whole thing squared, if 9p squared plus q squared is equal to 12 and pq is equal to -3. So I'm just gonna, okay guys, so I'm gonna go through all of these so that people can get the full pleasure of actually getting these answered in front of their faces. Okay, so yeah, this is for my beloved grade what is it, my beloved grade 10s. Okay, so there it is. We are given that 3p plus q, the whole thing squared. Now we are asked then, if 9p squared plus q squared is equal to 12 and PQ is equal to negative 13, is it negative 13? Then what is the value of 3p plus q, the whole thing squared? So what you do first and foremost, we take that 3p plus q, the whole thing squared, and what we do is we expand it, because we can see that we are given 3p plus q, the whole thing squared. So we open two brackets because this is to the power 2 and there's a plus sign in between. So then we open those two brackets. What's 3p times 3p? We get 9p squared. And then what's 3p plus 3p times q? That gives us 3pq. Then what's q times 3p? We get positive 3pq. And then last but not least, what's q times q? That gives us q squared. Okay, so hopefully you can see this and it's all good and well. Okay, then we get the following: 9p squared. Remember, they said something about 9p squared plus q squared being equal to 12. So what we do is we rearrange these terms. 9p squared, we bring the q squared with its positive to come next to pq squared. P squared. So 9p squared plus q squared, and then we add these like terms. What's 3pq plus 3pq? It's 6pq. Okay. Now remember, they said something about 9p squared plus qp plus q squared, and they said 9p squared plus q squared is equal to 12. So I substitute in the place of 9p squared plus q squared the value of 12. Does that make sense? Then I say that's followed by what? By a plus, which is this plus. This has entirely been replaced by 12. Does that make sense? Then I follow that by plus. Then there's the 6. So I write the 6 down. In the place of PQ, what did they say? PQ is equal to negative 13. So what I do is in brackets, I put in the place of PQ negative 13. But remember, the relationship of 6 and the PQ is one of multiplication. Hence, I put brackets when I substitute the what? The PQ. Okay. Yes, I will. I definitely will. And then that's equal to 12 plus, remember, what's 6 times negative 3? Negative 13. So a positive times a negative gives me a negative. And then what's 13 times the 6? All right. Someone tell me what's 13 times the 6. I know the positive times the negative gives me a negative, but what's 6 times the 13? Thank you, Naledi. We have negative 78. Then we take the 12 minus the 78. We subtract. We get a negative. 12 minus 78 gives us a negative what? Drum roll, drum beat, drum roll, drum beat, drum roll. Answer is... Thank you. Negative 66. Okay. So guys, this is basically, remember quotes, this is 12 minus 78. Be very careful. This is not 12 plus 78. It's 12 minus 78. Hence the answer is negative 66. So guys, questions like this are just questions to check, if you can... you can basically understand and apply your mathematical knowledge to basically answer a question. You are given a particular expression and they say if 9p squared plus q squared is equal to 12, and you look at this and you're like, how is this going to relate with this? Okay, you're not going to see how this is going to relate to that and this until you take this binomial squared and you actually FOIL it. Then you can kind of see, oh, look at this 9p squared, oh, that q squared, oh, the relationship between the two. Oh, that's why they said 9p squared plus q squared is equal to 12. And then 3pq plus 3pq gives me 6pq. Oh, the pq, they said the pq is negative 13. So that means in the place of pq, I substitute negative 13. So we substitute 12 in the place of 9p squared plus q squared because we are told that 9p squared plus q squared is equal to 12. And then we substitute that. We substitute in the place of pq negative 13. And then we apply our mathematical knowledge, multiply out, add and subtract, and there the answer is. Okay. So yeah, these are questions that just require our It's like it's mental gymnastics, if you would call it that. Really. Okay, then let's look at number 1.3. 1.3 says write 0.7 as a common fraction. Write 0.7 as a common fraction. Okay. And people, please take note. It says clearly show all your working details. But the thing is, this 0.7, okay, remember when we were doing the conversion, when we were learning about rational numbers, what did we say a rational number is? We said a rational number is a number that can be written as a fraction, right? A rational number is a number that can be written as a fraction, where the numerator and the denominator are integers, and where the denominator can never be 0. Okay, and when we look at decimals, there are two types of decimals we get for rational numbers, and these two types of decimals are: one, we get what we call terminating decimals. Okay, and terminating decimals, this would be a typical terminating decimal, okay, where after the comma the number stops. There's no continuation of numbers, a repetition of numbers infinitely. So a terminating decimal is where there is a limited number of numbers after the comma. It could be 2 numbers, it could be 1 number, it could be 3 numbers, it could be 8 numbers, it could be 11 numbers, but they eventually come to a stop. That's why we call them terminating decimal. The word terminate means to end, to come to a stop. The second type, as Naledi has said, is recurring decimal. Recurring decimal simply means after the comma, the numbers just repeat. It could be 1 number that repeats after the comma, and remember that we put a dot to signify repetition of numbers, or we can put a line to signify the repetition of numbers. Okay, so remember, this year is like saying 0.1 forever. This year is like saying 0.12 1 2 1 2. So the 1 2 repeats itself. That's why we call it recurring decimal. This is like saying 0.813 813 813, and 813 never stops, right? It goes on infinitely. Okay, so that's what we call recurring decimals. And recurring decimals can actually be converted from recurring to a fraction. Terminating decimals are, like I said, after the comma, these numbers, they come to a stop. They don't go on forever. That's why we call them terminating decimals. So it could be 1 number after the comma that terminates, or it could be several numbers after the comma and they terminate. So for instance, this is 875. After the 5, the decimal number comes to a stop. So that's why we refer to these as terminating decimals. So rational numbers can be expressed as either decimal numbers that are terminating or decimal numbers that are recurring. So what we have here is a terminating decimal. In grade 7 and in grade 6, you should have learned how to convert a terminating decimal to a fraction. So this one is quite simple, guys, straightforward. Because this is a terminating decimal, all we do is we simply move the comma once to the right. That shift to the right simply means that we now have a whole number or an integer that we can represent in the numerator. But that movement to the right means a division by 10. Okay, so however many times we move to the right, it means that's the number of zeros we are going to have after 1. So 7 over 10 is simply 0.7 written as a common fraction. Okay, let's just do another example. If I had 0.83, for instance, and they asked me to convert this to a common fraction, what I would do is I would move the comma 2 times. When I move the comma twice, I now have 83, which is the number in the numerator. But because I moved 2 times to the right, how many zeros does that mean I have after the 1? I have 2 zeros. So therefore the number is 83 over 100. Then what I usually do is I will check with my calculator to just check that this 83 over 100 is simplified, because I need to always be able at the end to write my fraction as a simplified fraction. So 83 over 100 would be my common fraction. Okay, so this is what we do for terminating decimals, guys. For terminating decimals, we always do this to be able to represent our answer as a common fraction. Let me just do another example. Let's say we had 1,5728, for instance, and they asked us to write this as a common fraction. All we would do is we'd move the comma till the end, 1, 2, 3, 4 times. Okay, so that means we have 15728. How many times did we move to the right? 1, 2, 3, 4 times. So that means I divide by what? By 10,000. So that's 15,728. Okay, very important. Over what? Over 10,000. That's 1, 2, 3, 4. I have how many zeros? 1, 2, 3, 4. So that is over 10,000. Okay, and then you take this, plug it into your calculator, and then see if your calculator simplifies it any further. That number that is simplified would be your final answer, your final common fraction. I hope that makes sense, guys. So for terminating decimals, this is what we do all the time. And please, I would then advise you, because we did not have a situation in that particular question paper where we were supposed to convert a recurring decimal into a common fraction. This is grade 10, Women of Faith. We did not have a situation where we're supposed to convert a recurring decimal to a common fraction. So I would like to invite you guys to go to my YouTube channel, please. In the grade 10 playlist, I have a playlist, guys, in the YouTube channel for the grade 10s. That has been the playlist that I have been uploading videos that I've been doing of lessons that we've done in the holiday, because we did the syllabus a bit earlier than when the year started. And so some of the videos that I've done of lessons with regards to the real number system and how to convert a recurring decimal to a common fraction, I've actually uploaded those lessons there on my YouTube channel. You can go to my bio, the link is there. You can go and watch in that grade 10 playlist on the real number system. I've actually got a video there. It's very long. I think it's 1 hour and a bit, where it covers how to convert recurring decimals into common fractions. So I won't go into that because there was no question that basically was asking that in particular. I want to come back to this maths grade 10 paper again. So 2.1 says calculate the value of the following expression without using a calculator. Guys, this is a question for days. Calculate the value of the following expression without using a calculator. Now this is very key here, right? But I'm sure you guys can see something there. 0.072, the whole thing squared, minus 0.028, the whole thing squared. Okay, so very quickly, very quickly, let's look at this. It's a beautiful question, by the way. And you see, as a grade 10 learner who has done factorization, I'm sure you guys can see that this is actually a difference of 2 squares. Can you see that? Because this becomes a perfect square. This is a difference. This is a perfect square. And they've said without using a calculator, we need to calculate the value of this thing here. So we can't plug this into a calculator and write down the answer. They will know very well that you basically used a calculator, you see. So what you need to do is you need to open the 2 brackets as you typically would with difference of 2 squares. This here squared, you can write 0.072 and then another 0.072. Obviously, if you multiply these two, you'll get this back. Then one bracket will have a plus, the other one will have a minus. Here you have 0.028. You also have 0.028, which I'm sure, guys, you can clearly see that you can add these two right together. This is 0.072 plus 0.028. Now, if you do that column addition that you guys used to do, you remember column addition, guys? I mean, who doesn't remember? column addition. 2 plus 8, you get 10. You carry over something here, you get 10. All right, 7 plus 2, which is 9, plus 1, which is 10. You get the 1 there, so that's 1. So that's basically 0,1. So what we have in this first bracket is 0,1. Okay, now that's 0, 0. Okay, remember guys, 0,1, 0, 0. At the end of the day, it is 0,1. Also here we have 0,1. Okay, and basically what you are, no, actually, sorry, 0,1 here for the first bracket, my bad. But in the second bracket, okay, subtraction 0,072, 0,028, the subtraction of this. Now you know 12 minus 8 will give you 4. You cross that over, you have 6. 6 minus 2 is also 4. And then obviously you have 0,044. So you have 0,044. Okay, and then you can multiply those two together, okay, to get the value of the product. Okay, and you could basically go ahead now and you utilize your calculator, okay, because it wouldn't really like be of that significance when they've seen that this person has been able to apply difference of two squares, has been able to get the value of the first bracket, the value of the second bracket. Then of course here it's straightforward. That 0,1, if you multiply it by 0,044, you should be able to then get the final answer, and that's perfectly fine. So that's basically what they wanted to see from you as you basically approach this question. They didn't want you to just jump in and use the calculator. Thank you so much, Bongosi Mashlang. I really appreciate the roses, bruh. I really appreciate it. You are too kind. So that's basically it, you know. So I'm going to leave that one so that you can fill it in. And I know you confidently can, my beloved grade 10 maths gamers. Okay, let's go back to the question. Yes, then we got to the factorization. And people, I still feel that we still have people here that are not as hot as they should be when it comes to factorization. My beloved grade 10s, let me lovingly ask you to please not take for granted factorization. Okay, you guys need to be so affluent in your factorization. If you want to have a good time in grade 10, your factorization must be so good, guys. Please, 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 please. You cannot afford, guys, you cannot afford to have factorization as a challenge and an issue. Because if you do have factorization as a challenge and an issue, it will stand in the way of other topics that are yet to come. Okay, yeah, so please, 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 let's work on our factorization. Thank you so much, Bongosi Mashlang. Hey, your words, sir, they are really touching. Thank you so much. I think we did once meet in these streets, but it's just that I've been very busy and it's been very hard for me to go live for my learners here, but they know that I have been trying in the respective group to basically make sure that I do not cease from actually sharing some work with them so that they can stay in tune with the maths. Thank you so much, sir. Thank you so much. I really appreciate the gifts as well. I really, really like. Thank you, Ngos, like your name seems to suggest. Guys, come here. Let's look at this. All of you, when you look at a question, when they say factorize, you should be able to look at that question and be like, okay, I can already see what it is that is required of me here. So let's look at this one first. 4x minus x to the power 3. Now here's the thing, guys. Whenever we are looking at a question and we are asked to factorize, there are two things that I would like to ask you to do before you jump into the question. First, look at the question and check, first and foremost, how many terms you have in the expression. Doesn't matter which question it is. Always ask that first question. How many terms do we have in the expression? Please, please, please do that for me. All right. Now, I'm going to do something quite unconventional. Okay. And some of you may be like, but why is this necessary? Guys, if you look at these two terms, all right, if you look at the degree of the expression, for instance, this is 4x. Look at the exponent. It's 1. This one is x to the power 3. Okay. There's something about when we factorize, we always take out the sign of the first term when we factorize. But the degree of the expression is very important. For instance, the degree of this expression is 3. All right. Why? Because the variable x, the highest exponent that we have is x to the power 3. Are you with me? So I hope you guys understand that. So for the purpose of this question, what I would really ask us to do, we can actually from the get-go apply something that I refer to as the sign change rule. We do that because when we factorize, what we want is to have the variable with the highest exponent to be our first term in the expression. All right. So I would really encourage you to do that. Okay, because the degree of the highest expression, if we have the degree of the term with the degree, the highest degree, which is x to the power 3 first, then we can basically work from there. So what I would then advise is to actually rewrite this as x to the power negative x to the power 3 plus 4x. That's basically, very important. Then if you look at this, the term that has the highest exponent is x to the power 3. It's negative. It's followed by plus 4x. Then that means we can take out the sign of the term x to the power 3. Because we take out the negative sign as the highest common factor. What are we left with inside the brackets? X to the power 3. Sorry, my bad. I am really misleading people here. So like I said, negative x to the power 3 plus 4x. That's important. Then when we take out the highest common factor, we remember this guy, S and L. We take out the highest common factor sign, highest common factor number, highest common factor letter. So if we look at this, what is the highest common factor sign? So the term that has the highest exponent, which is our first term here, has a negative sign. So what do? We take out the negative sign as a highest common factor. Remember, if the first term has a negative sign, we take out that negative sign as a highest common factor. Highest common factor sign we have taken out. Then we follow it with the number. Between 1, remember there's a 1 here and there's a 4. Obviously the highest common factor, that 1, we take it out as well. But here, that negative obviously will stand or represent the negative 1 that we are talking about. Then we move on to the letter. X to the power 3 and x. Which one is the highest common factor? The common base with the lowest exponent. So that means we take out x. Does that make sense? So we have negative x as our highest common factor. Then we open brackets. Once we've taken out the highest common factor sign, number, and letter, then we can basically open the bracket. What is inside? Negative times what gives us a negative x to the power 3. Obviously, whatever we have should be positive. If we've taken out one x, there are 2 of these x's that we need so that we can get x to the power what? X to the power 3. So that means we write x to the power 2. Remember that exponents, the laws of exponents says when we are multiplying same bases, we keep the base and then we add the exponent. So that's how we will get the x to the power what? 3. I hope that makes sense to you. Then negative times what gives us a positive? It's negative, guys. Negative, right? Because the negative times the negative will give us back the positive. Then negative x times what gives us 4x. Obviously, we just need the 4. Do we need another x? No. because that x is compensated. Okay, so we have x squared minus 4. Then inside the bracket, we still can factorize further. So we don't stop at highest common factor, but we open two brackets and we continue. We do not finish. We are not done here. And many times people think they are done. Okay, so this is a typical 2-in-1 factorization where we can see first and foremost highest common factor is required, and then when we look inside the brackets we can see that difference of two squares is still left to be done. So yes, what is the square root of x squared? We have x and x. What is the square root of 4? It's 2 and 2. And then remember, our negative sign means that we have different signs inside the what? The bracket. So we have plus, we have minus. Whether you start with the minus, you end with the plus is of no importance. What matters is that you have two different signs inside the bracket. And what's beautiful is that with your factorization, do you see that the x term is first and the constant term follows? And this is because we first arranged our expression before we could factorize. And this is very important, guys, that if you look at this expression, the variable with the highest exponent needs to take its rightful position as the first term, and then it is followed by the variable with the least exponent than the to the power 3, and it still has its positive sign. It's positive 4x. Then we factorize highest common factor. Remember, when we factorize highest common factor, we always look at the sign, the number, and the letter. So the first term we will always take out the sign of that first term as the highest common factor. We don't ever miss that out. Then we look at the number 1 and 4. Obviously 1 has been taken out, that's negative. Then we look at the letter x to the power 3 and x. We take out the common variable that has the lowest exponent for our highest common factor. That's why we took out x. What's left inside? X squared. What's left on the other side? Negative 4. But we are not done, because inside the bracket we have difference of two squares. So we continue, we finish up, and then that's basically our final answer. Does that make sense, guys? I hope we are clear here. It's very important, this thing. Let's look at the next question. The next one says factorize x squared plus 15x minus 54. So this is a typical quadratic trinomial. Okay, this is a typical quadratic trinomial. Okay, this is grade 10, this is not grade 8, so don't worry. X squared plus 15x minus 54. So what do we do here? Here, with the typical quadratic trinomial, we know that we look at the three terms, we look at the constant term, we look at the factors of 54, which when we multiply give us negative 54, but when we add those numbers, they must give us the coefficient of x, which is positive 15. Something that we know is that when our constant is negative, that means different signs inside the bracket. But the factor of 54, that is the highest, will have the positive sign according to the sign of the middle term. Okay, so here we are going to use the quadratic trinomial approach. We look for the factors of 54. Okay, so Shohi has helped us out already, indicating there in the comment section. So we open firstly. Okay, so firstly we ask ourselves, how many terms in the expression? 3. Secondly, what is the highest common factor? It is positive 1. But does it have any effect on the trinomial? No. So what do we do then? We open two brackets. Remember, when we open these two brackets, it's like we have put the 1 outside the bracket already. Okay, then x squared. How do we form x squared? We know it's x and x. That will give us our x squared. Shohe has already helped us out and basically found what the factors of 54 are. Remember, there's 1 times 54, there's 2 times 27, there's 3 times 18, there's other factors as well. But we choose the ones which when we multiply give us 54, but when we add them give us 15. So Shohe has said 18 and 3, they work perfectly. Because 18 times 3 is 54, and subtracting these two gives us 15. But when the highest factor is positive and the lowest one is negative, as per the sign, because the constant negative sign tells us that the signs are going to be different. But the highest factor of 54 will have the positive sign. Okay? Different from when if it was negative and negative, it would suggest that if it was negative and negative, the highest factor would have had the negative sign. Okay? So therefore, there is our factorization. We are done. We are done. We are so done. That's how we factorize a quadratic trinomial, guys. Whenever the sign is negative, it means different signs inside the bracket. But whenever the sign is positive for our constant, where x squared is positive, then if the constant is positive, it means same signs inside the bracket. And it's as simple as that, this factorization of a trinomial, guys. So we only have this one problem here. But please, my YouTube channel, I did this extensively. If you feel like you are still struggling with quadratic trinomials, with factorization, you can go there. I did that thing extensively. You can watch until you are so good and blue in your face. Number 3, let's look at the factorization of y minus xy plus x minus 1. Okay. Yes, when you've got this down, and I know many others who are here who are not commenting in the comment section. You guys are so good at your factorization. It's so pleasing to my eyes to know. Okay, it's pleasing to my heart. All right, you have not lost your mojo, and this is what I want. You can't lose your mojo, guys. You can't, as the year goes on, lose your mojo of factorization. You need to be so good at factorization. Next year in grade 11, I'm going to be expecting you to be hella good at factorization. In grade 12, I'm still going to be expecting you to be top-notch Tokoziles in factorization, because you need that skill for the next few grades that are coming up. So you need to really grasp this skill so well. So yes, Shokhe said this is grouping factorization. Very easy. Y minus xy. So we look at this, we're like, okay, we can group these two because there's something common which we can take out. We look at x minus 1. All right, there's something there. We're going to see. So let's look at this. Take out, we group these two. We take out y as a common factor. We're left with 1 minus x. Okay. And then here, for x minus 1, our first term is positive. So let's keep positive 1 out and write x minus 1. Okay? Yeah, because the highest common factor, we can take out 1. We're left with x minus 1 inside the bracket. If you look at 1 minus x, guys, look at 1 minus x. The order there, we want the order where the x term is first and the constant term follows. So we apply what to this bracket? We apply something that we refer to as what, guys? What do we apply? We apply the rule that we call the what? I'm waiting for someone to say it. I won't say it. We call it the what? Because the order, this is 1 minus x, this is x minus 1. We can get this 1 minus x to be the same as x minus 1, but we need to do something first before we can have that happen. We can't just swap this around at will, because 1 minus x is different from what x minus 1 is. All right, so what do we do? KFC. Did I just hear KFC? No, man, what is this? KFC. Kentucky Fried Chicken. We have Kentucky Fried Chicken here. We do Kentucky Fried Chicken. Babeska forever. Yes, Naledi. Sign change rule. Yes, Babeska forever. Take out the sign. So in other words, we change the sign of our outside term. In other words, we take out the negative sign. That allows us to swap around x minus 1. Guys, look at this. You take this negative sign, you put it back. What happens? What's negative times x? Let's just take the sign. Forget about the y. Negative times x gives you the negative x back. Do you see that? Then negative times negative 1 gives you back the positive 1. Isn't this beautiful? Yeah, we call this the sign change rule. It's like some sort of like medical operation we perform on expressions. You know how we have CPR for people that are actually out of breath and cannot breathe properly. So we apply SCR to this binomial 1 minus x. We take out the negative. We change the sign, we change the order, we change the sign, we change the order, we change the sign, we change the order. Do you see what I mean? We change the sign, we change the order. All right? And then that allows us to have what I call common brackets. You see, we now have common brackets. And this is how many terms in the expression? We have one term, we have a second term. So we have something that is a highest common bracket now, which is what? X minus 1 is a common bracket. Does that make sense? X minus 1 is a common bracket. And then inside we have what? We have negative y plus 1. Okay. Yeah, negative y plus 1. Okay. And then, guys, please, you see this thing here, the fact that we have negative y plus 1. We have to make sure that our variable term is not negative. So what we do, guys, very easily is we take out this negative. We can take it out, this negative. When you take out this negative, what gets left behind? Y minus 1. Remember, if we take out the negative, everything inside the bracket, the sign changes. Very important. So we take out this negative. If we took it out the negative, what are we left with inside the bracket? Y. And then if we take out the negative for the positive one, it will left with negative 1. Okay, so we just take out the negative so that inside the bracket we have a variable that's positive for the first bracket, we have a variable that's positive for the second bracket, and then that negative sign is just on the outside. So that is fully factorized, guys, fully factorized. Remember, when we have a negative sign as a first term, we must take out that negative sign as a highest common factor. Whenever we have a negative sign as a first term, we must take out that negative sign as a highest common factor. So we do that there, and we are left with the answer negative into x minus 1 into y minus 1. Variable first in the bracket, as you can see, which basically perfects our answer so that there is no question. Even the person who's marking us will not have any reason for not awarding us all the marks, because we have basically ensured that everything is taken care of as it ought to be taken care of. All right. Okay, let's see the other one that follows. We have t squared into r minus s. Okay, minus r plus s. So look at this one, hey? So once again, you look at this and you're like, how many terms do we have in the expression? So we have t squared into r minus s, that's one term. Minus r is a second term. And plus s is a third term. But what you can see is that it's almost as if they've done a first step here of factorization. It's like there was t squared r minus t squared s, sorry, and they basically took out the common factor for us and they created a bracket, almost as though like for these two terms we are supposed to also have another bracket. Does that make sense? So we're actually supposed to continue where they started. This guy started for us. You know, this guy, he started off the question for us and he left it hanging. Now it's almost as if like the teacher comes and says, okay, let me just put this question in a test for the learners, where there's a learner who started the question, but now we need to finish off on his behalf. Does that make sense, guys? I hope you guys understand this. So this was like it was like a grouping question, but the thing is, the person started but did not finish. Does that make sense? Oh no, Junior, you are too kind. That is a compliment and a half. You are too kind, sir. Okay, so let's finish off what this person has started. T squared into r minus s. They've taken out basically the common factor, r minus s. Now let's look at these last two terms. Look at the first term, it's negative. Look at the second term, it's plus s. So what do? We are going to factorize, take out the common factor here. What is the common factor between negative r and positive s? What do you notice about the sign of the first term? What does that allow us to do, guys? Negative r plus s. So what are we going to do? because we want to take out a common factor here. They've already done it for us for the first, basically the first two terms that were there. Okay, now here, negative r plus s. Okay, how do we take out, what do we do here? Negative r plus s, we take out, highest common factor is negative what? Negative 1. Thank you very much, Chloe. Okay, and then we are left with what inside the bracket? R, and look at this. Negative times what gives us a positive? Minus s. Yes, thank you, Cindy. Very good. Very good, Cindy. You're spot on, girl. Spot on. So proud of you there. Very nice. Very well said. Now that we are here, guys, can you see the common bracket? So you see, they basically, like I said, this is no different from this question. You guys, when I asked you about this, factorize this, you said grouping, didn't you? So this is like them looking at the first two terms and taking out a common factor. Then they are left with 1 minus x. And then they leave this for us to do, right? Okay. And then it's only after we do this, then we find out, oh, okay, we will potentially have two common brackets. But these are not common brackets, so there's something we need to do. Okay. So here again, okay, look at the question. T squared into r minus s minus r plus s. So what did they do? They had already taken out the t squared and wrote r minus s as one bracket. Now the last two terms, there's a negative r plus s. What did I say to you guys? Whenever you are given an expression and the first term in what you are looking at is negative and they say factorize, you take out the negative sign as a highest common factor. Please, guys, please listen to me when I say this. You take out the negative sign as a highest common factor. You take out the sign of that first term. It's very important, this thing. Okay, and then you are left with what inside the bracket? R minus s. And what that does is it creates a common bracket of r minus s. Okay, so I don't know, user 793781886156. You said you don't understand, but I don't know if you still don't understand. Babes, forever, you helped us out there. R minus s is a common bracket. So now the next step is to take out what? The common bracket, which is what? R minus s. Then on the left, what are we left with? T squared, right? Yes, thank you, Cindy. Cindy, you're amazing. You're amazing. Yeah, Cindy, babes, forever. I know that's one of your kids there that are obviously on the live. You guys are amazing. So what are we left with when we take out r minus s? On the left, we're left with t squared. On the right, we're left with minus 1. You see that? It's beautiful, guys. It's beautiful. Are we done? No. Look at this bracket. Is there anything that we can factorize? And this is a question you need to ask yourself. You may think that you are done, but always check each bracket and see, is there anything more that can be done? R minus s, no factorization can be done. T squared minus 1, ooh, flower girl, you do. Difference of two squares on the second bracket. Flower girl is, man, flower girl is like, man, yeah, you must get your flowers. You know what I mean? It's like you need to get your flowers for real. Okay, there we go. Difference of what? Two squares. So open two brackets. We know that it's going to be a positive bracket and a negative bracket. Our signs are sorted. Square root of t squared, we've got t. It's like an odd tt, you know. Square root of 1, we have 1, 1. That's done. That's done. Can we factorize any further? No, we are done. Okay, and guys, this is how we munch up all the marks. We leave nothing, like no crumbs. We eat everything, no crumbs left. Everything, all the marks, they just come. Everything, guys, everything, everything. It's that level 7 that kind of borders 100%, or 100% just becomes something that is, it's not something that's, yeah. Thank you so much, Junior. I hope you can sort of like, that is a very important thing that you are saying. It needs absolute concentration, like absolute concentration. That's why, guys, I don't understand a maths class where there's chaos and learning does not happen, where there is absolute silence and people are just in this thing. Because if you guys want to master the maths, man, you need to be in this thing. You need to be in this thing. You need to fall madly in love. Like, you know, you guys were talking about Valentine's this past what, but you know nothing about Valentine's when it comes to maths, man. You fall in love. You fall deeply in love with maths. I'm telling you, you think about maths day and night, and man, my goodness, it follows the concepts, the understanding, and then you just are able. Okay, and this last one that I want to check out very quickly, x cubed plus 1. Yeah, you see, even that one, judgment of answers. Whoa, Asuka. Where will people ever grow up if they are doing that? Okay. Okay, here we were asked to simplify. So this is a typical algebraic fraction where you have a binomial at the top, you have a trinomial at the bottom. But you can clearly see that this is a sum of what? Of 2 cubes. So that means factorization of sum of 2 cubes needs to be applied. You could think here in the denominator that this is a typical quadratic trinomial. You can factorize it, but you need to look very closely. You know, I mean, the factors of 1 are 1 and 1. And you can't add 1 and 1 and get -1, or subtract 1 and 1 and get -1. So that means you cannot factorize this trinomial. It's unfactorizable. But let's look at this at sum of 2 cubes. Remember, for sum of 2 cubes, okay, you open a binomial bracket and then you open a trinomial bracket. And what do? We say, what is the cube root? First and foremost, we establish, is this a perfect cube? Yes, x cubed is a perfect cube. What is the cube root of x cubed? It is x. The cube root of x cubed is x. Okay. What is the cube root of 1? It is 1. Okay, the cube root, sorry, not the square root, the cube root. Okay, so then you have x, all right, and then the sign of the original expression. Okay, x, the sign of the original expression, the 1. Okay, does that make sense? Okay, so the cube root of x cubed is x. The sign of the original expression, if it's positive, then it's going to be positive. If it was negative, you're going to have a negative. Cube root of 1 is 1. Then for this binomial bracket, the trinomial bracket, you square the first term to get the first term of the binomial bracket. Why? Because x times x squared gives you x to the power 3. You square the last term to get the last term of the trinomial bracket, because 1 times 1 gives you the 1. Then the signs inside the bracket are very simple. You'll have a negative and a positive. It's always the case, guys. Plus, minus, plus. If you have a plus for the original sum of 2 cubes, then you are going to have plus, minus, plus. Very important. Plus, minus, plus. Plus, minus, plus. If you have the sum of 2 cubes for the original expression, then basically when you factorize, if it is truly 2 cubes, then obviously you have plus, minus, plus. It's always the situation. And then to get this term here, the product of these two, x times 1 gives you x. You always check the product of the 2 terms. Forget about the sign, just the product of these two without the consideration of the sign. X times 1 gives you the x, which is your middle. So that's done. So we have x plus 1 into x squared minus x plus 1 over x squared minus x plus 1. Now check this out, guys. I'm sure you can see that the numerator and the denominator, the relationship is one of multiplication over division. There is no separation of addition and subtraction between the brackets. So you can cancel freely, guys, freely. In other words, this divided by that. What is something divided by itself? It's actually equal to what? To 1. So our final answer here is what? X plus 1, because it is in the numerator, the x plus 1. So it's like x plus 1 over 1, if that makes sense. But this is x plus 1, because x plus 1 divided by 1 gives you 1. Remember that this divided by that gives you 1. Okay, and then the final answer is x plus 1. You cannot cancel 1 and 1. You can't do that. We don't cancel across an addition or subtraction sign. X plus 1 divided by 1 simply gives us x plus 1. Okay, and that's basically how you do that. All right, so the division of between two expressions, okay, the division between two expressions simply means you factorize the numerator if possible, you factorize the denominator if possible, and somehow through your factorization there is bound to be something that will cancel. Whatever is the same for the top and the bottom, where there's a relationship of multiplication and division alone leads to cancellation if there are two similar things, numerator and the denominator, because something divided by itself is actually 1. So that's why we basically say they cancel each other. Not that they cancel each other and they disappear, but more of like this divided by itself is equal to 1. And that's why basically we get a final answer, because this x plus 1 gets left behind. We get an answer of x plus 1, which is in the numerator, and that divided by 1 gives us x plus 1. So I hope that is very clear for those who are watching. Okay, so that's basically that full on paper there that I looked at, and very, very critical, very crucial. All right, in the same vein, guys, for the grade 10s, I also gave you this one to do. All right, I gave you this one to do. Okay, and in this one I want to look at two questions, because these two questions were the ones that I found most people struggled, okay, with those particular questions. Okay, I sent this as well in the group in the week, and some people did it. Like, I mean, I was so pleased with some people, okay, but like there were some people that really were struggling, you know, with factorizing and so forth. And this is the thing, guys, you need to work on your factorization. We need to work on the factorization. Okay, it needs work, this factorization, because you're gonna find that the factorization is going to affect a lot of things if you don't sort it out. Okay, we need to sort it out. Okay, we need to sort that factorization out. So there are two problems that I wanted to look at. Okay, the expand and the simplify. Which group are we talking about, sir? Which group? We're talking about we're talking to the grade 10s here. The grade 10s, the importance of knowing how to factorize, because this is a grade 10 like sort of example paper, if you will, you know, and these are the kinds of questions that the grade 10s need to be fluently able to answer without, you know, breaking a sweat, if you know what I mean. Right, so those who are asking me in the comment section, when am I doing exponents, when am I doing this, when am I doing that, guys, all of that, you know, is going to come up. I'm not in any way today going to do anything that's exponent related. If you guys are there already at your schools, that's fine, keep on going. There will come a time I will definitely go through that, but for now I'm finding that there are things that are harassing me that you guys are still not grasping as of now, you know. So I just want to look at those things, and then yeah, so for instance 2.2 and 2.3, okay, were the two things I wanted to really look at today in this particular paper. Everything else that's on here, I mean, if there's people that are looking at this paper and they're like, that question, maybe you can indicate in the comment section, but for now these are the ones I wanted to look at, and I wanted to look at the method, and I wanted to look at the approach, and I wanted to look at what it is that's important when it comes to these questions. Because if you look at the mark allocation there at the bottom, 2.2 is 5 marks, 2.3 is 6, you know, and when people were sending me their responses of the work that they were doing, like, it was a shock to me to see that so many people are struggling with addition of algebraic fractions and the method that they ought to apply. Yes, I'll be posting this on YouTube. Don't worry. Don't worry. I will. Let me remove this. Okay, this is the question, guys. Let's look at number 1 first. Okay, let's first look at number 1. 1 over 1 4x squared y minus x minus 2 over 3x to the power 3. Now, first things first, this is addition and subtraction of algebraic fractions. Very important. That's the first thing we need to establish. So, in earlier grades, you have some foundational knowledge that helps you to navigate the space of addition of fractions. And that is what? This is a simple question that you would have done in grade 9, grade 8, grade 7. All right. Typical question you'd have done in grade 7, grade 8. Yes, Z. Very good, Z. So when you look at something like this, 1 over 2 plus 1 over 3, what you do first and foremost, there's a rule in fractions where it says you cannot add two fractions until the denominators are the same. So what we do to help us in the mission of establishing same denominators is we use what Z has said is called the LCD. But remember, the concept of LCD comes from the concept of LCM. What is LCM? The lowest common multiple. But because these two numbers are in the denominator, we now call it the LCD. So it's nothing different from what an LCM or lowest common multiple is. That number, all right, which is the lowest multiple that goes into 2 and 3. The lowest multiple. So if you multiply in twos, if you count in twos, you have 2, 4, 6. If you count in threes, 3, 6, 9. So basically the lowest common multiple between 3 and 2 is 6. So that is your LCD. So what you then want to do is you want to fashion your denominators so that they are like this LCD, which is 6. So what would you multiply 2 by to get 6? You would multiply by 3. But remember, what you do in the denominator, you must do in the numerator. Same thing with 3. What would you multiply the 3 by to fashion it after 6? You multiply by 2. But what you do in the denominator, you do in the numerator. Remember, 2 over 2 is like 2 over 2 is like multiplying 1 over 3 by 1. Doesn't change anything. So the identity of 1 over 3 does not change when you multiply by 2 in the numerator and multiply by 2 in the denominator. It's just that we are able to achieve the mission of getting 1 over 3 to be expressed as a equivalent fraction so that the denominator is 6. And that's very important. Okay, the concept of equivalent fractions. So now we have 3 over 6 plus 2 over 6. Guys, now that the denominators are the same, and check this out, the denominator goes nowhere. Why? Because this is not an equation, it is an expression. So the denominator goes nowhere. The denominator does not disappear, doesn't leave, doesn't get eliminated. Okay, denominator does not leave. So 3 over 6 plus 2 over 6, now that the denominators are the same, the rule says you can add the numerators. So the answer is 5 over 6. And that is the answer. Okay? Right. So I hope we understand this thing of LCD. Now, let's come here. How many fractions do we have here? Okay. First and foremost, there are 1, 2, 3. Because 1 can be written as 1 over 1. That's very important to have that. Okay. What do we have in this denominator? We have 1. What do we have in this? 4x squared y. What do we have here? 3x to the power 3. So first things first, the LCD, all right? The thing is, we don't have something to factorize in the denominator. Typically, whenever we're doing algebraic fraction equations, we factorize the denominator if it is possible. Then after that, we find the LCD. So we need to first factorize the denominator. That's the method, okay? But since our denominators are all monomials, meaning they are one terms, we basically we cannot factorize in this case. This is grade 10, guys. Grade 10. This is algebraic fraction expressions, not equations, but expressions. So LCD, when we write down the LCD, okay, I'll do that. When we write the LCD, guys, we write the sign, the number, and the letter. And listen to me, LCD. So we are going to look at, this is 1, this is 4x squared y, this is 3x cubed. So if we look at the highest common factor number, obviously this will be a positive LCD. That's always the case. What is the lowest common denominator number between 1, 4, and 3? And that is what's important here. We're looking for the lowest common multiple between 1, 4, and 3, because we need to write down the LCD for these three fractions. What is the lowest common multiple number between 1, 4, and 3? Okay, I see someone says 12. Snoopy says 12. Shochi says 12. Sbani says 12. So guys, I'm hoping we are all on board with 12. Thank you. So the highest common the lowest common multiple number between 1, 4, and 3 is 12. You guys are 100% spot on. We are done with the number. Now let's move on to the letter. We have x first and we have y. But x here, we have x squared, we have x to the power 3. Now when we go for the letter, we always choose the common base with the highest exponent. I hope you guys are seeing how important this is to understand. We go for the common base with the highest exponent to write down the LCD. Okay. Remember, when we took out the highest common factor, we usually go for the common base with the lowest exponent when we want the highest common factor. And we're factorizing. But now when we want the LCD, we go for the common base with the highest exponent. So here, guys, there is no x, right? But let me tell you something that you don't know. You could actually say there's an x to the power 0. Guys, what is x to the power 0? It's 1, right? So even though you don't see an x variable, but the reality is that there would typically, in your head, you should know there's an x to the power 0. Does that make sense? So that's why basically we say common base, because the x is common for all denominators here, but it's just that it's not until such time you actually are sensitive and aware of the fact that, oh, in actual fact, there's an x to the power 0 here, but we do not see it. And there are these things in life that we don't see, but they are there, they exist. Okay? Just because you don't see them does not mean that they don't exist. Anyways, that's a story for another day. But let's look at the x, guys. So we go for the common base with the highest x. So what would be our LCD for the variable x? Let's look at x alone. Forget about y. Let's look at x alone. Which one would we choose? X squared, x to the power 3, x to the power 0. There's an x squared, there's an x to the power 3. So we said we go for the common base with the highest exponent. So my question to you, which base here has the highest exponent? X squared or x to the power 3? Thank you very much. Offense, you rock. You're a rock star. It's nobody. You remind me of Proverbs 3:15. You're a rock star. Pretty P, thank you so much. M, I think you have converted, you have changed your ways to the right ways, because you said x squared initially, but it's x to the power 3, guys. Okay. Okay. Please, guys, it's x to the power 3. So we first start with the x variable. Then let's move on to the other variable. There's also another variable, and that is what? Y. Y. Okay. We also will go for the common base with the highest exponent. Remember, there's a y to the power 0 that we could put there. There's also another y to the power 0 we could put right there. But which base has the highest exponent here? Is it y to the power 0? Is it this y? What does this y has? It has y to the power 1. Okay, and then this y to the power 0. Okay, so we go for the base with the highest exponent. So that is y. Guys, here is our LCD. Here is our LCD. Here is our LCD. I repeat, this is your LCD, guys. It's 12x to the power 3 y. That is your LCD. The number is 12. The variable x, we go for x to the power 3 because that is the common variable x base that has the highest exponent. And then for y, we go for y to the power 1 because that is the common base that has the highest exponent. I repeat, guys, for LCD, you go for the common base. For the variables, the letters, you go for the common base that has the highest exponent. The number is very simple. 1, 4, and 3, you have 12, which is your lowest common multiple. Okay. I hope you guys are with me. Are you with me? Are we on the same page, guys? Because if you don't know how to write the LCD, these things here, they become a pain. They become such a pain. Okay. So now, okay, thank you. I'm glad we are. Now I want to finish off. After we write the LCD, we need to now fashion our denominator so that it is the same as the LCD. What do we need to multiply 1 with in order to get 12x cubed y? We need to multiply by 12x cubed y. But what we do in the denominator, we do in the numerator. Make sense? Now, what do we do to 4x squared y to get 12x cubed y? 4 needs to be multiplied by 3 to get 12. X squared needs to be multiplied by x to get x cubed. Y is fine because we already have y. So we multiply here by 3. X. But what we do at the bottom, we do at the top. Very important. Look at 3x cubed. What do we multiply 3x cubed to get 12x cubed y? All right. We multiply, thank you flower girl, by 4y. But what we do at the top. Now be very careful. This is x minus 2. It's a binomial. So we put brackets around the binomial and we put the 4y. Very important even to take the 4y and put it before the bracket. Before the bracket. So that we remember that this negative needs to go inside with the 4y and be distributed so that we can establish what needs to be established. This is very important. Guys, this makes me know that the denominator now is the same, 12x cubed y, for every single one of these for every single one of these fractions. So I can just write my single 12x cubed y. All right. Some of you I know will write it independently for each fraction. That's fine. Okay. But I like writing it once and for all. So what's 1 times 12x cubed y? 12x cubed y. plus, what's 1 times 3x? That's 3x. And then last but not least, minus 4y into x minus 2. This 4y needs to come here, because remember, this is multiplication of x minus 2 and 4y, but we can change the order around. It doesn't have to be, because multiplication is commutative. So you can write the 4y first and follow it with the x minus 2. And this negative sign needs to then be distributed inside this bracket. So that's why I'm going to have 12x cubed y plus 3x minus 4xy. You distribute the negative as well to the negative 2. You get plus 8y over 12x cubed y. Okay. I hope we are good. 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 If there are any questions, please ask in the comment section. Let your voice be heard. Let me know. Let me know. Olga, when you say no questions, you mean? No cancellation. Why would you want cancellation? Okay, remember here we are adding fractions, guys. Right? And remember, do you remember what I said here? What did I say? You guys did additional fractions when you were in lower grades. You established the denominator according to the LCD. When the denominators are the same, what do? You can now add the numerators, guys. Please. What's the whole point of doing all of this that we are doing? Why are we finding the LCD? It's because we want to make the denominators the same, so that can allow us the opportunity to do what? To add what's in the numerator. Okay, remember here we had the opportunity, once the denominators were made the same, to add the numerators. Okay. All right, so this is an expression, guys. Please, let's differentiate. Okay, this is an expression. It's not an equation. So the denominator cannot disappear. It does not disappear. We establish the LCD so that we can add the numerators and keep the identity of the expression. Okay. It's a different story when we are dealing with an equation. Okay. Now all we are interested in now, we are going to see if we can't have, do we have any like terms. If there are no like terms, guys, then it means our answer gets left like this. Okay. It means our answer gets left like this. Okay. Why do we have 8y? Negative 4 times x is negative 4xy. Negative 4y times negative 2 gives you positive 8y. Remember, when we were establishing this denominator according to our LCD 12x cubed y, what did we multiply 3x cubed with to get 12x cubed y? We multiplied by 4y. What we do at the bottom, we do at the top. Then what do? We have a binomial multiplied by a monomial, but there's a negative sign. This negative sign times this 4y needs to be distributed inside the bracket. This is what we did. Negative 4y times the x gives us negative 4xy. Negative 4y times negative 2 gives us positive 8y. Then we leave it like this, guys, because what was the point of getting the denominator to be the same? What was the whole point of doing that? It's because we wanted to eventually do what? We wanted to be able to add the numerators. But if that is not possible, then we leave it like this. Okay, guys, what is an equation? 3x plus 3 equal to 0. This is an equation. An equation, you can solve for x in an equation. You can do that. 3x plus 3. This is not an equation. It is an expression. It's just two terms. You cannot solve this thing. You cannot solve for x for 3x plus 3. You can add these two things together, or you can maybe factorize them if they ask you to factorize them. But even in that, all right, this is an expression. Okay, an equation has a left-hand side and a right-hand side. An expression is simply a list of terms. There is no right-hand side. Okay, yeah. So there's a difference, big difference. Okay, so this is an expression, and honestly speaking, if there are no like terms and no factorization can take place, then we leave it like this. All right. Yeah, we leave it like this. Okay. Because remember, any factorization here should basically lead us to a place where we can cancel something in the denominator. But here we can't do that. We can't cancel. We can't cancel across an addition or a subtraction sign. We don't do that. Guys, it's like saying x plus 2 over 2. You can't do this. You can't cancel the 2 and the 2 because we don't cancel across an addition sign. Different story when you have something like this. Okay? The relationship between this bracket and this bracket is multiply. How many terms do you have in the numerator? 1 term. How many terms do you have in the denominator? If you put a bracket around, you have 1 term. So cancellation is possible because x plus 3 divided by x plus 3 is 1. You are left with the answer of x plus 2. Please, guys. But this is very wrong. We don't cancel across an addition sign. Okay, if we group factorize here, remember that group factorization is not going to lead to us being able to simplify this any further. So it's pointless. We just leave it like this. Any factorization, guys, should lead to a place where this can be eliminated. If it doesn't, then it's a waste of time. We don't have to do it. Okay, so yeah, grouping factorization, like I said, will not lead to the further simplification or the removal or the cancellation of 12x cubed y. So basically, we can just stop right there. Okay, yeah. Okay, I hope we are clear. I want to do this one as well because there were 2 of these problems that I wanted to do. Grade 10s, today you are getting a lot of airtime in the sense that I'm giving you my time today. You know, I'm sure you guys are saying, well, but you say you haven't been live with us for a very long time. But you see, the thing is, I'm giving you time now, and I hope you actually can see that. X squared minus 3x minus 4 minus 3x minus 4 minus x plus 1. Okay, here's another one. Okay. So this says simplify. Okay, just like the previous one. That previous one was also saying simplify. This is also saying simplify. Okay, so like I said to you guys, the method for these questions is 1. Factorize denominator if possible. Okay, because remember, why are they saying simplify? It's because this is a quadratic fraction expression. Why am I saying it's an expression, not an equation? There's no right-hand side. Okay? It's true, Junicia. You must have maths eyes. And the thing is, there are rules for everything in maths. You see, if you hate rules, you know you don't like being confined. You don't like the fact that there are things that you have to follow. There's rules. So we factorize step 1. We factorize the denominator if possible. Then we find the LCD after that. Okay. So I'm just going to look at this. Factorize the denominator if possible. Find the LCD. Okay, let's start there. Let's start here. So we have 3 over x squared minus 3x minus 4 minus x plus 1 over 4 minus x. If you look at this denominator, can we factorize it? Can we factorize this denominator, guys? X squared minus 3x minus 4. There's a constant term. It's negative. Yes, it's a trinomial indeed. It's a quadratic trinomial. It can be factorized. Okay, definitely can factorize it. Okay, the constant is negative. Okay, and since it's negative, it means inside our bracket we are going to have a positive and a negative sign. The highest factor of -4 will be negative according to the sign of the mother. Very important. Okay, so the highest factor will have the sign of the middle term. Very important. So we can factorize in actual fact here. Okay, so there's x 4 and 1, we have negative plus 1. Now, just to verify, a -4 plus 1 gives me, when I add the two, I get -3. -4 times +1 does give me -4. So this is 100% correct as far as the factorization I know. Then we have a negative x plus 1 over. Now, guys, 4 minus x. What can we do here? Can you see the order? 4 minus x. So what do we do here? We apply what? Because that's the type of factorization we can apply. We apply what? Junisha says common factor. Okay, it's like that procedure it's not the medical procedure CPR, but it is the, yes, we rearrange, we take out the common factor, the sign change rule, guys, the sign change rule. So if we take out a negative, we have x minus 4. Do you see what happened there? Okay, the first term is negative. We take out the x variable is negative. We take out that negative, we change the order, we change the sign, we change the order with x minus 4. But you see now we have a negative times another negative. Two signs next to each other suggest multiplication of those signs. So ultimately, the sign change rule that leads us to a sign in between that is positive. Okay, I just showed you guys that there was a negative there. There's another negative I took out that leads us to a positive. Very important, that change there. Okay, yes, it does. It does. Naledi, thank you so much. Tabo Gianna, spot on. Babes Got Forever, at least, yeah, I know. Okay, guys, factorization done. Do you see why we factorize the denominator if possible? Unlike the previous problem, factorization was not possible, so we went straight ahead and found the LCD. In this case, factorization is possible, so after that, we can now find the LCD. Now, let's go there. LCD means what? You remember what do you say about LCD? Now we have binomial brackets. So for LCD, we go for the common bracket. Now, you see, since there are brackets here, we are going to go for common bracket with highest exponent. Okay, but if it's common, then we just take that common thing. Okay, and then we take out that. So let's look at this. X minus 4, x minus 4. For two different fractions, x minus 4 is common. So that means LCD x minus 4 is definitely being thrown in there. Then we have x plus 1. X plus 1 is unique. All right. But since it's unique, we know that x plus 1, we could have here an x plus 1, but it's not x plus 1 raised to the power 1. It's x plus 1 raised to the power 0. Next to this, x plus 1 raised to the power 0. But we will go for the common bracket that has the highest exponent. So that means we need to write x plus 1 as a product of x minus 4. This is our LCD. Okay, this is our LCD. Are we together, guys? Hey, x minus 4 and x plus 1. So if you don't factorize, it becomes difficult to see the LCD. That is why we start by factorizing the denominator if possible. Then 2, we find the LCD. The common bracket with the highest exponent, we write those as a product of each other, and then that is our LCD. Okay, now we are going to fashion 3. We need to fashion all our denominators according to the LCD. That allows us to add and subtract the numerator according to LCD. Now it's time to fashion our LCDs according to our denominators according to the LCD. So let's do this. 3 over x minus 4 into x plus 1. Remember, this is not an equation, guys. It's not an equation. It's an expression. So because it is an expression, we don't use the LCD to cancel the denominator. We use the LCD to fashion our denominator so that we can be able to add the numerators. So if you look at this x minus 4 into x plus 1, this is already the denominator. Does that make sense? This is x minus 4 into x plus 1. It already has the identity of the LCD. So what would we multiply the denominator by? We'd multiply by 1, and we'd multiply by 1 at the top as well. So that does not change this fraction. Let's move on to the second fraction. So let me just say times 1 here, times 1 here, just so that you guys can kind of see what's happening here. Let's look at this second fraction. We have x plus 1 over x minus 4. We want to fashion our denominator like the LCD. So what's missing here from this x minus 4 in order for it to be like our LCD? Do you guys see what's missing next to the x minus 4 in order for it to become like the LCD? What do we need to multiply x minus 4 with in order for it to become like the LCD? Because remember, we need to fashion all our denominators according to the LCD. So we need to fashion our x minus 4 so that it is like the LCD. What's missing here? What do we need to do to the x minus 4 in order for it to have this x plus 1? Exactly, we need to multiply by x plus 1. But remember, guys, what we do at the bottom, we do at the top as well. Do you guys see that? Hey, I hope you are with me, guys. This is an expression. We don't use the LCD to eliminate the denominator. We use the LCD to fashion our denominators so that they are like the LCD. Guys, I'm going to come back to this again. Why were you doing this in earlier grades? 4 and 3, you would find the LCD, guys. Why were you finding the LCD? So that you could find the LCD, fashion. And then ultimately, what did you do? 9 over 12 plus 8 over 12. Then when the denominators were the same, you went ahead and you did what? You added the numerators, and then you would write the answer. Please, guys, please, for expressions, listen to me. Fashion. Okay, so now, yes, Barney, to make the denominators the same, we use the LCD. We use this LCD. The LCD is sort of like the example that we need to fashion all of our denominators in accordance to, so that we can ultimately be able to add the numerators, because the denominators are the same. I'm sure now you can see, guys, that the denominators are obviously the same. So what I'm going to do now, because I see that the denominators are the same, I'm just going to write that single LCD because it's fashioned now. What do we have at the top? 3 times 1, which is 3, plus what do we have at the right hand side? X plus 1 into x plus 1. Now we need to FOIL this. So we have x squared plus x plus 1, okay, equal 3 plus, now inside, x squared plus 2x plus 1. Okay, then 3 plus. Now we remove the bracket. You take this plus sign, you distribute it to each term. Obviously the plus sign won't change anything inside the bracket. We have x squared plus 2x plus 1 over x plus 4 into x plus 1. Okay, guys, I hope you see what I did here. So this here, x plus 1 into x plus 1, I foiled it. X times x, x squared. X times 1, x. 1 times x, another x. 1 times 1, that's 1. Okay. Yes. You see, and the reason why I can now freely do this is because the denominator has been fashioned according to the LCD. Now I have free reins to go there at the top and add the numerators. You see, now I'm going to add there. Have x squared plus 2x. There's a 3 plus 1 there, which is actually equal to 4. But guys, if you look at this, there's nothing more I can do here. Okay. Sorry, I said plus. Supposed to be minus. Sorry, my bad. Supposed to be minus. And yeah. So there's nothing more I can do here. So basically I have x squared plus 2x plus 4. Okay. X minus 4 into x plus 1. I can't do anything more than this because you can't factorize this. The factors of 4 are 2 and 2 or 4 and 1, and there's no factors that you can add together that can give you 2. Does that make sense? Because plus means same signs according to the mother, and obviously that cannot be factorized. So this x minus 4 into x plus 1, that's just there. And you can simply stop right there. You can't go any further. You could FOIL what you have in the denominator if you want to, so that you can have a trinomial at the top, a trinomial at the bottom. It's just that the fact you can't factorize the numerator so that something cancels in the denominator. So basically this is where this stops. It stops smack bang right there. Okay. Guys, I hope we are seeing the light where these questions are concerned. We cannot cancel anything. We end right there. The addition in the numerator was able to happen. We're able to add the like terms after multiplying out, and we're able to arrive at a trinomial in the numerator. The denominator is still the LCD that we had established. All right, so we can then stop right there and we can end. You know, there's nothing more we can do beyond this. Sometimes what's beautiful about these questions is that yes, you can please FOIL the denominator. Okay, let's FOIL the denominator there. Okay, you can definitely FOIL the denominator. X squared minus 4x plus x plus 1, which basically means we have x squared plus 2x plus 4 over x squared minus 3x plus 4. It's plus 4. It's minus 4, sorry. That was minus 4, sorry. Minus 4, because negative 4 times 4 is negative, yeah. So that's minus 4x plus x. So yes, that's x squared minus 3x minus 4. Some grade 10s would cancel. But yeah, but like I must say there's a bit of leniency here. When you do leave it in this stage, that's fine. You won't get penalized. If you leave it here, that's fine. Yeah, but I know some teachers do insist that you go ahead and you actually go ahead and end where the denominator has been also FOILed, but that's also fine. If you end right there, there's definitely no problem with that. No, you cannot cancel the x squared. Remember, we do not cancel across an addition and subtraction sign. You can't say x squared divided by x squared, but there's an addition and subtraction sign. Let me just show you how crazy or terrible that is. Guys, if you guys are insisting that, let's say you have 2 plus 3 over 2 plus 5, and you guys are saying that 2 and 2 need to be cancelled. Okay, try and understand. What's 2 plus 3? It's 5. What's 2 plus 5? It's 7. So basically the answer here is 5 over 7. What happens when you cancel the 2 and the 2 across an addition sign? You know, this answer loses its integrity. It loses, you know, what it actually means. because if you cancel these two, what are you saying? Do you say 2 and 2 are gone? Do you say 1 and 1 are left? If you say they are gone, then you are left with the answer 3/5. Okay? If you cancel this and this, then you are left with 3/5, which is not 5/7. That's wrong. If you are saying 1 and 1 are left, then it means we are left with 1 plus 3, which is 4, 1 plus 5, which is 6. It still loses the meaning of the actual answer. So I want to say to you, and I repeat, you cannot cancel across an addition and subtraction sign. We do not do that. we don't cancel across an addition or a subtraction sign. I wish you guys can make an important note about that, okay? Because too many students, too many learners, they do that a lot. Okay? Yeah. All right. Very, very important. We don't cancel across an addition or subtraction sign. So my beloved grade 10s, I am going to have to hold and hang my badge right there. But that's what I wanted to explain to you today. Okay. The ones with division and multiplication, offensive Mia, I would really encourage you to please go to my YouTube channel. Like I said, I did algebraic fractions with division and multiplication, because those ones are pretty straightforward. The thing is, there, division and multiplication, cancellation is easy, right? You can do it. Okay, you can do it. There's no problem. Let me just actually do one. I think there's one that was there in that particular problem. Let me just see. Oh, okay, I think this one was where there was division alone, but like there was a trinomial at the top and a binomial at the bottom, and yeah, okay. But this was like straight division. X squared minus 12x plus 27 over 4x squared minus 12x. Let's see, I'll just do this one and I'll see if I can't find another one just quickly. Let me just do that. I think let me do that as a concluding note. Uzi says, I take it as if give us advice for the new week. Okay, so let's just very quickly before that. So there's this question where x squared minus 12x plus 27 over 4x squared minus 12x. Okay, so the x squared term definitely at the front, x squared term at the front, so that's good. So obviously there's a trinomial, okay, quadratic in nature. There's a quadratic binomial here, all right, also quadratic in nature. So if you look at the numerator, you can obviously factorize here. Okay, open two brackets, right? This is a trinomial. The constant term is positive. What does the positive mean? It means same signs inside the bracket. They are same according to who? According to the mother. So the positive means same signs, but same signs that are negative. So I know there's a negative and a negative there inside the bracket. X squared means x and x. Okay, and then the 27, the factors of 27, that basically when I multiply give me 27, when I add they give me 12. So Shohi has helped us out there. We've got 9 and what? And 3. Very good. Then we go to the denominator. Highest common factor there we can see is what? Is 4. Then we are left with 4, in fact 4x. Remember, highest common factor, we take out the base that has the lowest exponent. So highest common factor number 4, and that is positive 4 because the sign of the first term is positive. Highest common factor variable x, because we take out the common base that has the lowest exponent. For our highest common factor, we take out the base that has the common base that has the lowest exponent. So that's x. What are we left with? X minus what? Minus 3, right? And really, when you check it, it works out. It works out very nicely. Now here, guys, you can cancel. Why can you cancel? Because the relationship of x minus 9 with x minus 3 is one of multiplication. Division is there. 4x and x minus 3 have a relationship of multiplication. So therefore, cancellation is possible because we are not cancelling across an addition or a subtraction sign. So that's why cancellation is feasible. Make sense? And what are we left with? X minus 9 over what? 4x. Now, you can't then get tempted to cancel x and x. Why? Because x is across a subtraction sign. Can you cancel x? No. No. We can't cancel now. Yeah. We can't. It's a danger. It's a danger if you cancel. Right? So I hope you guys are getting it. It's not about surely that cancellation. Cancellation is not possible across an addition or a subtraction sign. The danger is lurking, guys. It's lurking. Right? Let me just see if I can't find one other multiplication and division one. Maybe that's a bit more sporadically spread out. Some other things, other factors just. No, you can't. Elisha told you can't. You can't simplify further. Why? We cannot cancel across an addition or subtraction sign. Unless when you can suggest to me what do you want to simplify further there? Tell me. Eh? Tell me. What more do you want to cancel there? What more do you want to simplify here? Explain to me, Elisha. What more do you want to cancel here? What more do you want to take care of here? I'm waiting for Elisha to indicate what, by how, it's fine, not by cancelling. No, remember, this is not a perfect square, guys. This is not a perfect square. X is not a perfect square. 9 is a perfect square. Negative is a difference, but x is not a perfect square. So not by factorizing. It's not feasible. Okay. What else do you want to say? Come on, tell me. Tell me all these things that you guys are thinking. I need to listen. I'm listening to you guys. Tell me. What more? What other things are you guys thinking in your head? Because I need to dispel all of the nonsense. We need to get the nonsense out, guys. We need to get the authentic truth in. The nonsense out. The falsehood out. The truth in. Okay? I just want to do this one as well. Then I'll go back to one more that has a multiplication and addition so that you guys can appreciate. So this one, simplify, but this has multiplication and division. Okay, so let's check this out. We listen, we don't judge. No. Me, I judge. I'm sorry. I don't listen and not judge. I listen and I judge you. It's very important. Okay, here we are, guys. Look at this one. X squared minus 9 over 5x plus 10 times x squared plus 4x plus 4 over ax minus 3a. Divided by x squared plus 5x plus 6 over 5. So first things first, we have a fraction, top, bottom. I'm sure you guys can see there's no addition and subtraction between the fractions. So this is not a addition and subtraction type question. It's a simplify with multiply and divide. Now, when does simplify with multiply and divide? Guys, all we do is we look at each fraction and we check factorization. That's all. We look at numerator. I mean, for instance, look at this one. This one was a typical divide alone. So we look at the numerator, see if we can factorize something. Look at the denominator, see if we can factorize something, because cancellation is possible. Okay, look at this one, multiplication and division. So first things first, maybe we can even first change the divide here to multiply, because we know most that when we change multiply to divide, so before we even factorize, let's make sure divide has been changed to multiply. So divide times, what happens to this fraction? 5 over x squared plus 5x plus 6. Okay, so this is where we start. We start by first changing the divide to multiply, and then the fraction where we change divide. Okay, where we change divide. This is something, guys, you learned in earlier grades. Okay, so let's not the division, we change the divide to multiply, and then what happens to 2 over 8? It becomes 8 over 2. Okay, so I hope you guys understand that. I'm sorry about that, Elihle. Okay, yes, tip and turn, tip and toe. I guess if you say it's tip and toe, that's fine as well. Yes, so it's the tip and turn method. You change divide. Once you change divide to multiply, the second fraction always inverts. It's like you write the 2 over 8 as a reciprocal. Remember, multiply is an inverse operation of divide. So that's why the second fraction, it flips. Okay, it flips. Okay, all right, so that's why here that happens. And there's a mark there that usually people omit to get because they don't do it. Okay, so please, guys, let's not forget there's a mark tied in that. When you change divide to multiply, that's what happens. So very important. Then the second step is to factorize where possible. Factorize where possible. Now imagine if you are not good at your factorization, then you'll have a problem. So this one, what type of factorization do you guys see here? What factorization do you see here? X squared minus 9. This is? Thank you, Shoche. It's difference of 2 squares. So I'm just going to write dots here. So that means open 2 brackets then. We have x, we have plus 3, we have minus 3. That's factorized. Okay? Hope we are together there. Let's go to the denominator. What type of factorization do you see in the denominator? Highest common factor. Thank you. I love how someone is saying, is this grade 9 maths? Because yes, if you have been a grade 9 learner for a whole year, you will know that you actually at some point do this in grade 9 as well. So this is not like new in grade 10. It's something you have done in grade 9. I think in term 3, if I'm not mistaken. So highest common factor is 5. We are left with x plus 2. Very good. Okay, thank you so much, Hitekani Wankunguna. Times. What type of factorization do we have here? X squared plus 4x plus 2. Type of factorization, maybe you can even do the factorization for me so that I can just simply write down the answer. X squared plus 4x plus 2. Trinomial, Army, you are right. Definitely trinomial. So here we have, this is actually a typical perfect square trinomial. So factors of 2, same sign, so positive, positive, that is 2 and 2. Over. What about this one? Ax minus 3a. What type of factorization do you guys see here? Ax minus 3a. Really, Lupiwe, common factor. So we have highest common factor here as well. So yes, we take out the a, we are left with x minus 3. Very good job. And then 5, factorization? No. Denominator, x squared plus 5x plus 6. What type of factorization do you guys see here? You let me know in the comment section what type of factorization you guys beautifully, brilliantly see. trinomial factorization. Anyone who wants to recommend or wants to just give me the factorization as they see it in the comment section. Thank you, Simpiwa. Thank you, Mbasako. Say you're amazing. Elihle M, you're amazing. Londo Pandle, you're phenomenal. You're giving me the factors. Londo Pandle is like, he's pandering me here with the answers. X plus 3 plus 2. Beautiful, guys. Look at that. Look at you. Look at you guys factorize like you abo. Now we just play cancel. Okay. Yeah, okay. Now we just play cancel. Who wants to play cancel with me? Okay. Okay, so this is basically the method. This is my favorite part. So guys, listen to me. The cancelling part is possible. Why? Do you guys see an addition sign between the fractions? No. In the fractions themselves, do you see any relationship of addition between terms? No. This here is one term at the top, one term at the bottom. One term at the top, one term at the bottom. One term at the top, one term at the bottom. Now, that is why cancellation is possible. But please, guys, do not be tempted to want to cancel this x plus 2 at the bottom and that x plus 2. It doesn't work like that. We only cancel top and bottom, top and bottom. Doesn't matter where. Okay, so I might be in this fraction. If I have a bottom here and there's a top somewhere here, and they are the same, I can cancel them. All right, but you only cancel once with a particular bracket. Don't cancel twice with something. Okay, so let's start. Let's look at x plus 3. Does he have a friend somewhere down there? Nowhere here, no friend here. There is a friend there. Goodbye, x plus 3. They are gone. We cannot cancel them again. Does that make sense? X minus 3. Does he have a friend somewhere down there? X plus 2, no. X minus 3, yes. Goodbye, x minus 3. Okay. Any other friends? 5. Does he have a friend somewhere up there? Yes, there's a friend up there. Goodbye, 5. X plus 2. Does he have a friend somewhere up there? Yes, he does. Goodbye, x plus 2. A, does he have a friend somewhere up there? A doesn't have a friend somewhere up there. X plus 2, does he have a friend somewhere up there? Yes, he does. Goodbye, x plus 2. Who's left at the top? They are all gone. But who's left at the top, guys? Thank you, Elihle. Guys, please. There's one that gets left behind every time we cancel. So 1 times 1 times 1 times 1 times 1 at the top is 1 over. Please. If some people think there's nothing left at the top. And that's where the danger is. They think there's nothing left at the top. Let's look at the bottom. So everywhere where we cancel, there's a 1, 1, 1, 1, 1, 1. Okay, look at the bottom. Who's left at the bottom? 1 times 1 times 1 times a times 1. That leaves us with a at the bottom. So our answer, guys, is 1 over a. Do you guys now appreciate this thing of when do we cancel? Why do we cancel? When is it proper to cancel? So please, guys, whenever there's multiply and divide alone, one term everywhere, then cancellation is feasible. So the method I suggest here, okay, I know, Dunisha, that's exactly what happens and what learners do all the time, and it's dangerous. Please now, please grasp what I've said. Please, guys, I beg you. You guys want to score high marks for maths, man. You want to 100% this thing, do things that you've never seen before in the history of your family, in the history of your ancestors, in the history of your community or wherever you stay. Then please don't mess around with this thing. So for the multiplication and division, Step 1, you change divide to multiply if there's divide. And remember, when you change divide to multiply, the fraction that follows will swap around, tip and turn. Then you factorize where it's possible. You look top and bottom, factorize, play top and bottom, factorize. Then 3, you play the cancellation game. It leaves 1 where cancel, leaves 1 where we cancel, please guys. Okay. Yeah, if A was alone at the top, like Tabo Gianna says, then we would write A alone at the top. It would be A over 1, and then we would eventually say the answer is A. Okay? Yeah. Yes. Oh, Londo Punch. Look at Londo. Londo is like flexing their identity element. Flexing. Mr. Flexer. You can see, I'm sure, like, I can imagine Mr. Panda is probably like this buff guy who goes to the gym like every single day, you know. He doesn't miss a day at the gym. He's buff and fit and insanely fit, if you know what I mean. Okay. Alright, so I hope you guys can really relish and appreciate now this thing. Let's do, I'm gonna do 2 last ones for you for now. So multiplication, and now I'm gonna switch over back to addition and subtraction, okay, of fractions, because I'm sure you guys get the point now with the why cancellation, because you guys were confusing this cancellation thing. You think cancellation is possible for everything, but you guys don't know what the danger is with the thinking cancellation is possible for everything. Okay, let's come here again. Another problem. Now we have subtraction and addition. Denominator, 1 term, 1 term. So what do we need to do? Factorize the denominator if possible. But you can clearly see factorization is not possible. So what do we do then? We find the LCD. LCD between 1, 12x cubed, x squared, and 3x. So what is the LCD, guys? Between 1, 12x squared, and 3x. Remember, I said we write down the LCD according to the number and the letter. So there's 1, there's 12x squared, there's 3x. So what do we say? The lowest common multiple between 12 and 3 and 1 is what? Is 12. Then for the variable, guys, for the variable, x squared and x. X squared and x, we go for the common base that has the highest exponent. So our LCD is 12x squared. So between 1, 12x squared, and 3x, our lowest common denominator, which comes from the concept of lowest common multiple. Remember, between 1, 12, and 3, the lowest common multiple is 12. I don't know if you remember from earlier grades. 1, 2, 3, 4, 5, 6, 7, 8, 9. You get 12. You get 3, 6, 9, 12. You get 1, 2, 3, 4, all the way to 12. And then you would look at which one is the multiple that is the lowest between 1, 12, and 3. And it would be 12. Okay. I'm sure you guys remember that. Okay. That was for multiples. Then for the letter, like I said, we go for the common base that has the highest exponent. So that's why we have x squared as the variable LCD. 12 is the LCD for the number. Very important, guys. So the LCD is 12x squared. Now what are we now going to try and do? We are going to try and fashion our denominator to be like the LCD. So what do we do to this one to get it to become like the LCD? We multiply by 12x squared. What we do in the denominator, we do in the numerator. Then we move on to the second fraction. It is already like the LCD. So what do we do there? Okay, there's x minus 4 in the denominator, 12x squared. So we do what? We multiply by 1. But remember, what we do in the denominator, we do in the numerator. So now I'm going to strategically write the one that I'm multiplying with before the bracket so that I can know to do what? To distribute. And I put the bracket there for x minus 4 because it is a binomial term. That's very important. Okay, very, very important, guys. So what I've done is that because I want to fashion the LCD to become like this 12x squared, I know I'm going to multiply by 1. But what I do in the denominator, I do in the numerator. I'm multiplying by plus 1 again here. But remember, there was a negative sign there already. So that plus 1 with the negative just remains as negative 1. Does that make sense? Okay. And then I put brackets around my binomial expression in the numerator because it is supposed to be like that. If there is one term, a number that I'm going to multiply with the binomial, I put it in brackets because this is a binomial term. Again, this is a binomial term, so I put brackets around it. Very important, guys. Okay, very, very important. Over the 3x that was there. Then I'm going to fashion my 3x to become like the 12x. So what do I need to multiply 3x to get 12x squared? You can simply say 12 divided by 3. What do you get? You get 4. And then x squared divided by x, I get x. So that means I multiply by 4x. What I do in the denominator, I do in the numerator. So I just take that 4x, I put it before the bracket. Guys, there is wisdom in what I'm just showing you now. You put the binomial brackets for your two terms in the numerator. Please, please, please. You can see the wisdom. If you don't put them, you are not going to remember that, oh, this monomial needs to be distributed inside the what? The binomial. So that's why it's key to put brackets around a binomial terms. Please, people, please, please, please. Then you can see that all my denominators now are 12x squared because when I multiply for everyone, it's 12x squared. So I just write a single 12x squared because I know they will be like that, all the denominators. That gives me free rein now to multiply my numerators. What's 1 times 12x squared? 12x squared. What's negative 1 times x and negative 1 times negative 4? Negative x plus 4. Hey, you see that thing? Hey, can go if there were no brackets. Yo, plus 4x into x, 4x into minus 3, plus 4x squared minus 12x. Hey, if there were no brackets, hey, I would have lost marks. Yo. And they say maths is difficult. It's easy this thing. It's easy this thing. Okay, then adding of like terms. I can go here. We are adding like terms. Why? Because we have the same denominator. LCD has helped us to fashion so that we have the same denominator. So 12x squared plus 4x squared, like terms, 16x squared. You see? No problem. Then negative x minus 12x, negative 13x. Please, guys, if you don't know, you need a please use a calculator if you have to. If you don't know how to add like terms, negative x, negative 12x, the variable will stay the same. You just add the coefficients. So you say negative 1, negative 12. Use your calculator, you'll get negative 13. Don't guess and don't write things that are not due. Then plus 4 obviously stays there. Over what? Over 12x squared. Now, guys, can you go any further? There's no highest common factor because only a highest common factor will cancel this thing if there would be a highest common factor. Trinomial factorization, if it was possible, won't help me with anything with cancelling this thing, you know. So I stop right there. There, finished. Nothing more than this. The LCD allowed me to add the numerators. No problem there. Guys, the method is simple, man. Hi guys. Please, please, please. If there are more than 2 terms in your numerator, make sure to put brackets. Alright, so that when you multiply these things at the top, you can ensure that you distribute whatever you multiply by. And please, guys, take into consideration, if there's a negative sign, that negative sign will go into the bracket, guys, and will change things inside. All right, hope that makes sense. Then I wanted to do one more, and then hi guys, bye bye. After this, goodbye. All right, because the pressing thing for me was to do this addition of what you might call of algebraic fractions, because I hadn't done it yet. Okay, I hadn't done it yet. So this is one more. I'm sorry if I'm munching up your time. This is one more, then I will say goodbye. Okay. I will do those things in another lesson. I'm not going to do it now. Okay. There's a system that I'm working with here, and everything I do, I'm doing after one thing. I don't want to confuse and do many things at once. I am doing one thing at a time. So unfortunately, if you are at a certain place and you want that thing to be covered, if you want me to cover it, you're going to have to wait for me. Okay. Landy will tell me about it. Yeah. Hopefully you can see that. Okay, 1 over x plus 1. So what do? We look at the denominator, we factorize. Okay. X plus 1. Okay. Binomial, I put in brackets immediately. Denominator, factorize. Remember, factorize. So I take out what? 2x. What's left inside the bracket? X minus 1 plus, put in brackets, factorize the denominator, x plus 1 into x minus 1. Yeah, unfortunately, I am label. My schedule is not as orderly as I would want it to be. Okay, I teach at a school, and oftentimes there are things that have to be done. So I unfortunately cannot come up with a working timetable. So when I can, I do lives, but I can't do it all the time. So you just have to bear with me for now. So here we are, guys. Denominators, everything has been factorized. Now we are in the position of writing down the LCD. Let's look. X plus 1, is it common? We take the common bracket that has the highest exponent. X plus 1 is common. It's here in this one fraction and then in another one. So since it's common, we just write him once. Okay, x plus 1, he is there. Okay, he is part of our LCD. Then x minus 1, x minus 1 is also what? Is common. We write him as part of our LCD, as a product of x plus 1. Then 2x is unique, all right? And it is unique, so we also write 2x as part of our LCD. It's unique, all right? So 2x into x plus 1 to x minus 1 is our LCD, guys, for these 3 fractions. Very, very important. 2x into x plus 1 is common, into x minus 1 is also common. So the product of these 3 are what we refer to as our LCD. Now we need to fashion each of these denominators according to the what? To the LCD. I hope you guys understand. So here, who needs to be added onto x plus 1 in the denominator? Because x plus 1 is already there. What is not there? It's 2x and x minus 1. Can you see that, guys? 2x and x minus 1. 2x and x minus 1. Okay, so I already know that 2x, x plus 1, and x minus 1 are going to feature for every denominator here, because I'm going to fashion these, all of them, so that they are like this, right? All I need now is to just multiply what's missing. So x plus 1 is already there. What is missing? 2x and x minus 1. So on 1, we need 2x and x minus 1. Does that make sense, guys? I hope it makes sense. Then we say minus, we go to this second fraction. Who is missing? We have 2x and x minus 1. Who is missing? It's x plus 1. So that means that's x plus 1. I need to put as a bracket next to this x plus 1 as well. So x plus 1 into another x plus 1. Does that make sense? I hope it does. Then we come here. Who is missing? So the x plus 1 is already there. The x minus 1 is already there. So I would multiply by 2x in the denominator, which means I also need to multiply by 2x in the numerator. So that's like plus 2x into x plus 3. It's coming along nicely, guys. And all of these denominators obviously will be fashioned according to the LCD. Yo. Shortcut vibes. Did you see that, guys? What was happening there? The minute I am able to establish the LCD and I know it's right, the LCD I know is right, it's right for sure. Now I need to fashion all my denominators according to the LCD. So which I know my denominators will be like the LCD anyway. So I just write them. Then after that, all I do is I look who is missing. X plus 1 is already there. Who is missing? 2x and x minus 1. They feature in the numerator. Multiply to 1. Here, who is missing? X plus 1. So I just feature x plus 1 there. Here, who is missing? 2x. I just feature 2x next to the x plus 3. Guys, guys, I don't know about you, but shortcut vibes, I can sense it. Then all I do now is I multiply out, as Elisha said, expand and FOIL. So 2x into x, 2x into minus 1. Now, do you see, guys, that if your expand and FOIL in term 1 is still shaky, you're going to kill this thing. You're going to kill this thing. So that's why I'm saying that it's a build up. All of these things are build up, guys. Distributive property. These are all build up concepts. Build up concept from grade 8, build up concept from grade 9, build up concept from grade 10. You are in grade 11, guys. You must be a master of these concepts, because you will see the ease in doing the maths will come because these concepts for you are mastered. You must master everything. Everything must be mastered. So 2x squared minus 2x, guys. Amen, William. Amen. Hallelujah, William. Amen. You know how insanely excited that comment makes me feel, the one you just posted now. William says, last week he skipped this question. He wasn't sure what he was doing, but now I'm getting there. Please get there, William, because when you get there, I'll see you when you get there. See you when you get there. And it's not if you ever get there, you will get there. So I want to see you when you get there, my friend. Yes. Beautiful. Junicia, you were saying you want motivation the next week. I think you've got it. You are not born smart. You make you smart. Yes. Beautiful. All right. So let's go now. Okay, you see, we did the distribution. Now the negative sign is waiting to come in, is bending to come inside and have a dish with the family inside the house. So negative times x, negative x squared, and negative x, negative 1. You distribute that negative all throughout, plus 2x squared plus 6x. Remember, here we have 2x into x plus 1 into x minus 1. Okay, yeah. Then we add like terms. Like terms, guys. 2x squared minus x squared plus 2x squared. Yeah, so that one, 2x squared minus x squared. So 4x minus x squared. Or did I distribute nicely there? 3x squared, right? Minus 2x minus x minus x minus 4x. Then minus 4x plus 6x. That gives you plus 2x. And then last but not least, our constant term. That's negative 1 over 2x into x plus 1 into x minus 1. Guys, you can finish this off. All right, this here can be factorized. Go ahead, factorize it. You are going to see when you factorize it, something is going to cancel in the denominator, because once you factorize this, you have a relationship of multiply and divide alone. And when you have a relationship of multiply and divide alone, cancellation is possible. Okay, guys, I hope, oh man, I don't know, like, I hope you guys are seeing a semblance of good light as you know, are walking with me, and as you see that, no man, this thing is not as crazy as I thought it would be. Okay, yeah, because people like me that know how to do the trial and error method when it comes to factorization, know 3x and x, and then the factors of 1. Obviously here we have plus 1, minus 1, and if we quickly check, 3x times x gives you 3x, and then minus 1 times x gives you minus x. The 3x minus x gives you a 2x. Okay, over 2x into x plus 1 into x minus 1. So who cancels here? Can we cancel? Yes, guys, you can. This guy can cancel with this guy, because the relationship between, this is one term at the top, this is one term in the denominator. You can cancel these two. It's possible, because there's no addition and subtraction sign separating the brackets. You can cancel this and this. Then that leaves you with a beautiful answer of 3x minus 1 over 2x into x minus 1. And there we are. There we are. My beautiful people, that's where I hold everything. Okay, yeah. The trinomial AC method, the long trinomial AC method, I mean, obviously for some of us we could use that, right, where we multiply the a and the c. 3 times negative 1 gives you 3x squared, negative 3x squared, and then you find those middle terms, which will basically give you the 2x, and then you use grouping method, and then you find the factors by grouping 3x minus 1 into x plus 1. Okay, and then yes, you can distribute the answer if you want, where you actually have the answer as 3x minus 1 over 2x squared minus 2x. Okay, there's definitely no problem in that. That's fine. Yeah, that's fine. Okay, because that would basically make it compact, right? And remember, you would not be able to cancel this x and this x. Why? We do not cancel across a addition and subtraction sign. Guys, I hope you are internalizing this beautiful concepts that we have been able to solidify together. Okay, and I am sure in your textbooks there are problems galore that you can look at. I'm not going to give you any game challenges to do, all right, as I am confident that in your textbooks and even in your notes that you've done, you've had problems that you have been able to see that are there. Now, at least now you have some light that you can carry, which can help you answer and attempt the questions that you may have not had the confidence to attempt. Okay, grade 10s, let me say this again. You have the potential this year to really make your maths the best that it ever has been in grade 10. All of you have that potential if you are willing to pay the price and give the time and also practice the while. If you can do that and you can focus, guys, focus. Do not allow maybe momentary failure or not being able to do something be reason enough for you to cop out and not want to do it the next time, or not have the confidence to want to attempt it the next time. Sometimes you have to fail, and you have to fail many times And what I mean by that, I mean sometimes you may fail to grasp something the first time. That does not mean that you will never be able to grasp it. You need to give yourself the time to go over it again and again and again. All right. And when you do that, and then the day you finally master it and something clicks in your head and you're like, oh, I finally get it, then what you must do is you need to actually go and close yourself in some sort of room, find as many problems like the ones that you were able to see being done, and see that your body gets behind doing those problems yourself, so that you feel that I can do it on my own, you know. And when you do that, then mastery will come. And when mastery has come, guys, oh my goodness, do you know the feeling of confidence that you get when you are doing certain things in your maths class? Like it's phenomenal. It's out of this world. So please, 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 I believe in you. I really do. I believe that you guys can really do this. So please do it. Give yourself a chance, you know. And yeah, let's get the marks, guys. Let's get the 90s. Look at the number of people that are on the live. I don't know if you guys can see the number of people. It's 90 and above. That means 90% and above, guys, is just crying for us this year. It's like saying, come Duze, come to me, come closer, come a little bit closer. 90% is saying, let me hold you. Landiwe, Gera, Babeska Forever, Apelele, I'm Lebo, Tando, Landiwe, Sfiso, Siabulela, everyone, man. You know, let's do this, okay? Repeat what I did right now. Batman, you are funny. So I must repeat what I did right now. Okay, so very quickly. Okay, so what I was saying with the addition of algebraic fractions, 1 over x plus 1 minus x plus 1 over 2x squared minus 2x plus x plus 3 over x squared minus 1. What we usually do when we are adding algebraic fractions is we look at the denominator and factorize if possible. That is step 1. Look at the denominator, factorize if possible. X plus 1 cannot be factorized. We didn't factorize it. 2x squared minus 2x, we factorized. We took out the highest common factor, left with x minus 1. X squared minus 1, difference of two squares, we open two brackets, x plus 1 into x minus 1. After factorizing, step number 2, write down the LCD. Okay? Write down the LCD. How do we write down the LCD? We look at the common bracket or the common terms that have for the variable that have the highest exponent. So x plus 1, for instance, for two different fractions is common. It's not common for everything, but it's common for two. So we write down x plus 1. X plus 1, they are both raised to the power 1. So this x plus 1, for instance, is also raised to the power 1. This x plus 1 is also raised to the power 1. So it means x plus 1 is one of our common brackets. It features in the LCD. Then we write everything else that we identify as common as a product of x plus 1. So if we look at x minus 1, it's also common, raised to the power 1. So we write x minus 1 once as a product. Then 2x, okay, 2x is unique. So we have to also write it as a product as part of what we have in the LCD. This is our LCD. We then, after writing the LCD, have to fashion all of our denominators according to the LCD. So this denominator needs to be fashioned to be made like this LCD. So we check what's missing in this x plus 1 in order for it to be like this. There's the 2x and the x minus 1. So we just write that LCD for all of the fractions. Then we check what is missing. What's missing is 2x and x minus 1. So we know we are going to multiply in the denominator. We also multiply in the numerator. There you have it, 2x into x minus 1 multiplied by that 1. We look at this fraction. Who is missing? There's 2x and x minus 1. Here, who's missing? X plus 1. So we multiply by that in the denominator so that we have the LCD. We multiply by what's missing also in the numerator. There it is, x plus 1. We multiply them together in brackets. Binomial, you see this x plus 1, we put it in brackets because it's a binomial bracket. You see this x plus 3, we put it in brackets because it's a binomial bracket. And very importantly, this minus is waiting to come inside after the multiplication with what's missing. X plus 1 into x minus 1. Who is missing in the LCD? 2x. So we multiply by 2x in the denominator. We multiply by it in the numerator. There he is, 2x into x plus 3. Then we are now ready to what? To expand, multiply out, distribute, add and subtract like terms. So there we 2x into x, we got 2x squared, 2x into minus 1, we got 2x. 1 obviously does not really affect anything. X plus 1 into x plus 1, the negative is waiting, so we distribute, FOIL x plus 1 into x plus 1, we get that. The negative is then distributed throughout the terms. Negative x squared, negative x, negative x, negative 1. Then here, 2x into x plus 3, you see why it's important to put those brackets, because if we didn't, then we wouldn't be distributing. So we always put the brackets for our binomial terms, trinomial terms, quadrinomial terms, however many terms, we always put the brackets. Then 2x into x, 2x squared. 2x into 3, 6x. Then we add the like terms, guys. Negative x removes that bracket when we distribute that negative sign. Now we are free to add the like terms. 2x squared minus x squared plus 2x squared is 3x squared. Negative 2x minus x plus 6x is 2x. And then negative 1 there. Then we factorize the numerator because it's factorizable. Then, since the relationship between our brackets is multiply and divide, no addition and subtraction signs separating our brackets, we can cancel easily. Cancel. Then we are left with 3x minus 1 over 2x into x minus 1. Then, yes, of course, we could leave it like this, or we can just go ahead, distribute the 2x into x minus 1 and get 3x minus 1 over 2x squared minus 2x. We cannot cancel x and x. We cannot cancel y because we do not cancel across an addition or a subtraction sign. Okay, so this is how we add and subtract algebraic fractions that are expressions. Okay, guys, I love you. I really do. I've never loved strangers so much. I feel like this has been like the thing about my life, loving strangers so much. So yes, practice will definitely help, Batman. If you do that, then it will help you a lot. Please make sure that you practice. And please, like I said, there is no one here that cannot understand at the end of the day this method. If you first understand it, then you apply the method consistently, then you should be fine. You'll get to a place where this becomes easy, capizi, kanizi, manizi, kanizi, kachizi. You know what I mean? So guys, let me love and leave you. It's been a great session, very long. I didn't expect that I would stay here this long, especially for the grade 10s. I thought I would change it up and go and do a different grade, but you guys have received the benefit of actually having me on this session. So thank you so much. Please do have a wonderful, beautiful, amazing rest. Sleep easy, sleep tight, and may angelic forces be at your beck and call. At every corner of your household, angelic forces just sort of like minister and bring things to your remembrance, and nurture everything that needs to be nurtured in your heart, mind and heart and everything. And then in this coming week, just do what you do best. God bless you. Too much love. Take care of yourself, and we'll definitely see you again when the opportunity avails itself for me to avail myself for the grade 10s again. Please guys, there is my YouTube channel as well. You can go to the link in the bio. It's called Maths is a Game 5 to 7. I really appreciate those that have subscribed already. The channel is really growing, and the more you guys come in there, I'm able to really confidently also upload more of the videos and the live sessions that I do here. So this will be a very long one for sure, but I'll definitely put it up as soon as I can download it. But thank you so much, guys. Please take care until we meet again. And please, those who are wanting to know things that I've done previously, we've done factorization of trinomials and the other simplification type problems. Guys can find some of these sessions that I've done on the YouTube channel itself, and please go and watch those. Very long, some of them, because I speak a lot, but I guess that's what you get for chilling with me. Maths is a game, guys. Let's play, and let's play very well this week, and let's take care. Cheerio, toodles, goodbye. I have no idea, Moses. I don't know when again I'll be live. You guys will just have to make sure you put on your notification, and we'll see you when I see you again.